DeLorean hat. Those two make their rotation.
Nice. My hair was doing things I didn't appreciate starting right around 11th grade.
Last year with the VUEs.
I'm definitely getting there. It's either a mess or it's yeah, that one. They're sitting here.
Welcome everybody. We're gonna get started here in a couple of minutes. Maybe 1 minute. We'll give 1 minute and we'll start off because I know you've got quite a bit of content, Igor. So yes, we're gonna record it. It'll be available, so no problem starting right on time. And Mr. Bailey, you just let me know when you're ready or if you're good to go when I hit record. All right, let me hit it. All right, I'll start recording and we can jump in, Igor. Thank you.
All right. Hello, everyone. Igor Giffrin, I'm a solutions architect. There's tons of things that I'll be covering in the next, hopefully under an hour. And we'll go through things very quickly. So the idea is that we will look at LogStream as the security pipeline. We will look at something that you've probably seen, some of you, the big three security data challenges that LogStream solves. Then we will look at other things that LogStream can do for security, and there will be demos sprinkled throughout the hour. There will be 3 demos, and then we will dive deeper into a couple of things. A very practical example of using state data with streaming data, and also we will go to the deep end, writing correlation rules in LogStream using that state data. So hopefully that will all work out, and we will go through this quickly, and everybody will pick up some interesting bits and pieces from what you would like to learn. So, and let me know. So I'm sharing my slide deck. If you don't see it, just yell at me. So we will start from why we even need a security pipeline, right? So we kind of all know why, but let's just dive a little bit deeper. So for the purpose of the next few minutes, it will be just to think about security pipeline as the giant multiplexer with a brain, right? So you can throw any data source at it, and on the other end, it connects to your security analytics tools like your Splunk, Exabeams, Elasticsearches, and so on. Importantly, we'll talk quite a lot about replay. Well, we'll mention it. Well, I will mention it multiple times. So replay will be one of the things that will be mentioned. So I've been talking with very, very many organizations, and they seem to struggle with kind of the same pattern of issues with security data. And it was absolutely clear that there should be something in between security data sources and data destinations, like analytics tools, especially things like SIEM, UEBA, XDR. And the struggles were related to data transformation, routing data to different destinations, complex manipulation, aggregation, reducing volume, and just handling just-in-case data. So what it means is that everybody will have some data that they need to store for compliance and incident response purposes, and they may never touch it. They may need it urgently. So who knows, right? So, and that data can be literally petabytes of data over the past few years, and there's no good place to put it if you're using a regular SIEM. And another thing that some of the organizations struggled with is real-time alerts, right? So it's good to have your SIEM alerting on something a day later, but in many cases, it's too late. All right, so that's why, and we will stop there. We will look at the 3 security data challenges, the most common ones. The first one is data volume. So everybody collects a bunch of data into a security analytics tool, and As you start looking at your data sources, you start with your firewalls, maybe your authentication logs, but when you go up the stack, you will start noticing that some of the data is extremely voluminous. Things like your network flow logs, DNS logs, endpoint logs. And I noticed that some of the organizations just do not send that data for analysis at all. And in some cases, they don't really even store that data for any meaningful period of time. So this becomes very, very problematic if you start building your security solution or you want to have your good visibility into your security data. Second thing is lack of context. So we've seen a bunch of logs. Some logs tell us absolutely nothing. So this one tells me absolutely nothing other than there was some communication that Cisco ASA picked up, data going from my private IP to external IP, and that's it. So really not that helpful. I have no idea what that IP address is, and I don't know what the destination IP address is. And by the way, yeah, if you send it to your security analytics tool, Splunk will do GeoIP enrichment, but again, it will do it at the time of search usually, so that data can be stale. And this right now, an IP from North Korea, but maybe in a year it will be from some other country. So not very helpful. Last thing is data normalization. So this is absolutely critical for any security team. Unless you deal with just one or two data sources, you don't have time to search across your data sources individually, remembering all the field names. The example that I typically give is, do you know how many authentication mechanisms you have in your environment? How many data sources send authentication data into your security solution? And if you start thinking about it, you probably will say 1, 2, 3, but it's actually dozens, literally dozens. Somebody logs into your firewall, into application database. You may not necessarily have SSO for everything, especially for individual devices. And I'm not even talking about things like Active Directory and things like that. Then you most likely will just miss a bunch of things that you are not even looking for. Like, for example, that sys_create_by is from Salesforce. How would you even remember to search for that specific field? And also, if you don't have the usernames themselves normalized, how do you know whether it's even the right username? So it can be an email address for that username, or it can be alias for their admin identity for that username. So we will jump to a demo. So hopefully it will go a little bit better than on this picture. And I will cover how LogStream addresses those challenges. So let me know what you see side by side LogStream with what seems to be Splunk. All right, and on the left-hand side, we see LogStream, the latest version, almost the latest version. On the right-hand side is just sample dashboard from Splunk. And what we'll do, we'll start hooking up data from our firewall that comes via syslog, as very many firewalls do, to our Splunk instance. We'll use just a quick route, do pass-through for now. And very quickly, if everything works, so we'll start seeing data coming to our Splunk environment on the right. But passing through data is not super useful, right? So what did we get here? So we are staring at raw events, no structure, nothing we can do until we start messing with add-ons or writing regex or something like that to extract fields. No other visibility into what that means. So we can apply a pack that matches our with our firewall technology, for example, like Palo Alto, Fortinet, or Cisco. But in this case, this is a pipeline that is borrowed from one of those packs. And if I pick this pipeline, let's see what we'll see as the result of the processing through that pipeline. We'll actually dive deeper into this pipeline, but immediately we see things look much better. So we start extracting structure. We also, since it's Splunk, start extracting the common schema, right? So it basically allows us to not to guess what the field name is. It will be always SRC IP for source IPs and things like that. And we also started seeing just things showing up that's more useful. So we see what IPs communicating to other IPs. But this is just the beginning. Let's go and enrich this data further. So for this purpose, just the pipeline borrowed from one of the packs, slightly modified for this demo specifically. And we'll start from something simple. GeoIP enrichment, throw in MaxMind database, whether it's free version of premium one, and you will see the results here. So enriching data on the fly, giving it more contextual information. Like, for example, this IP address is from Germany. And it gives us a little bit more information. So we also see things, for example, where the traffic is coming from to our environment. And this is something that we can impress our bosses with, like this pew map. So, but it's kind of good, but we can definitely do much better. So we look at things like, for example, enriching data with asset information. And asset information is not that easy, but once you figured out where your asset information may reside, whether it's your configuration management database, CMDB, whether it's your Excel spreadsheets, whether it's a combination of thereof, maybe something is pulled from Active Directory, and you can put that data into LogStream as a lookup table, or we'll talk a little bit later about putting it into Redis. And once you do this, things become way more practical. If you start looking at the network map, I'm not staring at the IPs anymore. I'm looking at my assets on the network, understanding what those are. So, and here I see that it's not just an IP address. I see the host name. I see the criticality of this host. So it's marked as red here. So it's a critical customer database. Gives me lots and lots of context right away. And another popular use case is add threat intelligence information or threat intelligence feed. In this demo, it's a lookup with emergent threats threat intel feed that is open source threat feed, but ultimately it can be anything else. And we'll talk about this a little bit later. So what it gives us almost instantaneously is quick triage of who is attacking or potentially attacking my network. Like, for example, instead of researching each individual IP address that connected to my critical asset on the network, I can immediately see that I have known malicious IPs based on that threat feed communicating with my environment. So it's all good. So we enrich data, we normalize data. We still have this massive problem with volume, right? So let's go ahead and aggregate the events here. And we'll see what's going on this time chart first. And we'll see this number going down from 70 or so thousand EPS, or events per second, to something much smaller. Immediately, or pretty soon, we are seeing the aggregation spikes. Basically, here we are aggregating information or logs every 5 seconds or so, and you are in complete control how often you want to aggregate it, how you want to aggregate it. And we can see that this resulted in significant decrease of the volume of data that is sent to Splunk in this case. But that is just not sufficient, right? So importantly, we are preserving all the visibility that we need for our daily operations. We can still see what assets are communicating to each other assets. We can see that pew map. So we are not losing any meaningful information. And if you need to preserve data as is, full fidelity, for forensics, for incident response, you can route full fidelity data to your object storage, for example, and do replays for compliance events and things like incident response. So again, quick summary. So we literally solved these three big issues with volume, with context, and with normalization of data, all in the pipeline. So some of you have seen this before, but let's move on to something else. So I'm back to the slides, and we'll go very quickly over additional use cases before we start diving deeper into some pretty cool things. It's very natural to do simple things like pattern matching for all the data that traverses your security pipeline. In this case, when a log4 shell appeared first, everybody had this pattern that you see on the screen. You can basically throw it into your LogStream and see whether anything matches this pattern. You can issue alerts, respond, or analyze matched events almost immediately. Things definitely progressed, so it's not just a single pattern that is sufficient anymore, but this is how things started, right? And you could accomplish it within literally minutes to do that in your environment if you have a pipeline that has visibility into all the data that goes from your destinations to, sources to destinations. Another things that you can do with LogStream, and again, some of the things you're very familiar with. Ahmed wrote this fantastic blog, how to improve performance with Splunk, specifically pulling some of the fields into index time extracted fields. That makes things like Splunk absolutely fly if you start using things like tstats. You can increase performance of your most time-consuming searches from minutes or hours to seconds, milliseconds. So literally hundreds, 100x, 1000x improvement in performance. And this is not just improvement of performance, but also if you are on things like workload-based pricing, you can also just start not buying more CPUs if your load increases. This basically makes things just faster and cheaper. I mentioned quickly real-time alerting, right? So some of the questions that I commonly get, okay, so how exactly I'm throwing alerts and where? And this is really up to you. Some of the simple things, like for example, any event that should trigger an alert can be your event for an alert. And then you can just basically say that this event goes to a webhook as a destination, as an MP trap, or maybe goes to even Splunk, and you have real-time search for those specific alerts, and those are not that many alerts, so it doesn't really take that much time or horsepower to run that in Splunk or in any other tool. So alerting is relatively straightforward. Just as soon as you identify things, you can basically send it to Slack, to any solution that you use for real-time alerting. Other things, there's a couple of blogs. One of them is written by David, and those blogs talk about the importance of timestamps. For security, if you don't have your timestamps figured out, you're out of luck. Missing events, correlation is impossible. Events from the future. So it's just a huge, huge mess. And one of the things that are great with things like packs, some of the packs already have timestamps figured out. Knowledge pack goes very nicely and in depth around all your timestamps intricacies and caveats. But packs for Palo Alto, for example, and Syslog already have mechanisms to fix your timestamps. I'm going very quickly through this just because it's almost impossible to mention everything that we can do for pipeline for security in under an hour. Replay, just in case data, everybody has it, but nobody knows what to do with it really. So you either send it somewhere, you offload your SIEM and put it into maybe S3 bucket or some other inexpensive storage. And then bringing it back, rehydrating it, thawing it is close to impossible. So just in case data can be absolutely routed in parallel to your least expensive storage through security pipeline, through LogStream. And you can have full fidelity data for instant response or compliance. Data can be compressed, usually compressed, so you have additional savings. Brandon wrote a fantastic blog on automation of replaying data during incident response or case management through a SOAR solution like Splunk SOAR, Splunk Phantom. And what I like about replay, it doesn't require a developer or an environment or IT administrator to do this replay. So you can allow many others to replay data based on what they need. Some honorable mentions, so things that definitely we will not be able to cover in depth, but I mentioned threat intel feeds. Threat intel feeds are great individually, but what's even better is having your threat intelligence platform, if you have one, to actually feed LogStream. So you have combination of multiple threat feeds plus your own threat intel fed into LogStream, and everything that traverses LogStream can be matched against that data. It can be as simple as your IP addresses in threat intel platform, hash signatures, usernames, domain names, and so on. I mentioned GOIP data, Maxmine databases, free or premium ones, your choice. It's definitely one of the most popular use cases, very simple to implement in LogStream. Reverse DNS, if you don't want to stare at your IP addresses and you have DNS data that pulls more meaningful information about host names, reverse DNS is very important. Enrichment with asset and identity data, a little bit more complex, not from necessarily LogStream perspective, but just making sure that you have this data, right? And it's usable and it's up to date. So I've seen an organization that actually was updating that asset information every 30 minutes, right? So, and catching any asset on the network that wasn't matching the asset information, basically flagging that asset and investigating it immediately. So you definitely want to know what's on your network, what every asset on your network means. Volume reduction, reshaping, covered that. And now we'll jump to something a little bit more not necessarily interesting, but it is definitely interesting, but something a little bit more sophisticated. Streaming data and maintaining state. So if you start looking at LogStream, most of the things done basically on the fly. So the worker nodes, they don't maintain state. They are not aware of what other workers processed. And it's difficult to keep track of multiple events and persistence information as data is streamed through LogStream. Some of the functions do that in memory, like for example, there is aggregation function in memory. But if you think about how that works, it basically aggregates it per worker, and workers are not aware of what other workers aggregated in memory just because they share nothing. And it's definitely more interesting how you would possibly correlate data between different data sources, because you are processing a source at a time. So you kind of need to have things kept somewhere else to do those aggregations. So what would we want to do with the state data? So we would want to have data centralized somewhere so all the workers can have access to it, persistent, so it doesn't disappear when a worker goes down or rebooted or additional workers added. We definitely need it to work very, very fast, right? So anything on disk just will not cut it, right? So we cannot afford even several milliseconds for any kind of lookup. And we can definitely figure out some simple things with data structures for that state data, but to make it more universal, we want to have multiple data structures, not just key value pairs, but maybe lists, maybe sorted lists. And again, we don't want to just be developers every single day. We want to have something that is available out of the box. And many of you know that it is actually available in LogStream, right? So with Redis function that uses Redis as the underlying database, it's in-memory database. So again, the latency is minimal. A Redis function provides you with virtually all of the commands that Redis supports, even though if you don't see them in the drop-down list, you can actually use commands from Redis even beyond the drop-down list from that function. And Redis can be free. You can pay for it. The choice is yours, depending on what you want to accomplish. I use Redis locally on my machine, and I also use Redis in AWS. So it's a thing like Elastic Cache with AWS, depending on your requirements. And other cloud providers, by the way, provide Redis as well. So let's take a look at the practical example, and that's where we'll go to the second demo. So from this practical example, we'll take a look at something that really bugged me for a very long time, AWS VPC flow logs. If I talk with any organization that rolls out significant AWS presence, and keep in mind, this is really applicable to many, many other data sources, but I will take this as an example. So the first thing that organization does, let's collect things like CloudWatch, CloudTrail logs. So it's all good, application logs, and then they start looking at network. For network visibility, the typical solution would be just start collecting VPC flow logs. They are aggregated, and everybody thinks, oh, I can just throw them into my SIEM or log aggregation solution. And what many organizations discover is that they may have, let's say, a terabyte of logs in AWS, and suddenly it's about 20 terabytes of just VPC flow logs in the same environment. And what they end up doing is just not sending them to their log aggregation solution or security analytics solution. And it's very common across many, many organizations. Some organizations are clever and they just basically buy a solution that just looks at VPC flow logs. Like, for example, Palo Alto provides some of the solutions. But what they end up doing is they have two consoles. They need to switch between. Those consoles do not talk with each other. Those tools do not talk with each other. So you cannot correlate across them. So it's not a good solution. Anyway, long story short, so you can aggregate those logs and you can send the full fidelity data to least expensive storage like S3 and AWS. And it's not just aggregation, but you can also enrich data because VPC flow logs are not super interesting to look at. You don't know what they mean. And you can basically reduce the cost of your security analytics tools, still having this visibility into your network data in your AWS in this example, and also have this contextual information. All right, so let's go to the next demo. Let's see where my next demo is.
Oh, Igor, let's see if there's any, just pause for a second, if there's any questions out there before we kind of jump into the demo here. There's a lot of content. Thank you. That was great. Any questions? And if you have any, just definitely put them in the chat. We'll pop them in and make sure we get them answered. All right.
All right, let's continue, and definitely do not hesitate. So we, I think, doing okay on time. So if you have a burning question, definitely do not hesitate to either put it into the chat or just unmute yourself. And anyway, so for this example, there's a pack, AWS VPC flow pack It's all in the pack dispensary, so anybody can go and pull it from there and install it in your environment. I will not go through every single detail here, and there's a blog that matches this pack as well. But the idea here is something that we described here. So what we see here is that we can start aggregating events. We can basically clean up data. We can, for example, get rid of things that we may not necessarily look at. In this case, in this example, at least, it's east-west traffic, internal traffic. We will start basically just looking at external traffic only. And we also will aggregate or enrich data with our asset information. And in this specific case, we're pulling data not from this pack by this pack, but outside this pack with description information from AWS, right? So we may go back to this pack, but let's see what the results are. And this is something that comes from a real environment, even though it's small and your mileage may vary. But this gives you kind of a preview of what to expect from this kind of approach, right? So small environment, but we see significant reduction in number of events and significant volume of logs in terms of reduction. But we also enriching data at the same time. So this is, for example, in this table, we see that what we'll get from VPC flow logs, right? So we see source IP, destination IP. That's great. We can potentially look at IP location and things like Splunk sometime later, and it may be matching the original geolocation, or maybe not. Who knows? With this pack, we can plug in the asset information. In this case, it's a thing like, for example, tags, name tags from AWS description information and data for instances in that VPC. And also through MaxMind database, we're also pulling things for GeoIP location. And importantly, as you saw before during the previous demo, we are not losing any visibility into our environment. So don't mind the gaps here. So this is, you can see when environment was up or down. But ultimately, this is kind of what we see from that data when it's enriched and aggregated. So we see basically things like, for example, in our environment, the names of the assets on the network. We can also see how they communicate with other IPs or other assets on our network. We can slice and dice this information. So this allows us to not lose any visibility into the data that we care about, while significantly reducing the volume of the data, plus enriching the events with something that saves us tons of time instead of figuring out what that address 10.0.0.89 means on our network. And if you think about it, real-time or near real-time enrichment is very important, especially for ephemeral assets. So if you start correlating your CMDB, configuration management database, against your events, let's say a week later, that asset may have completely different IP address, right? So or completely, whether because it's maybe container instance, maybe DHCP assigned that asset completely different IP address. So kind of stating the obvious here, but very, very important thing. And I see a question here. All right. Yeah, so the question is around scaling a Redis backend without the ability of cluster. And yep. Absolutely. So this is definitely a good thing to mention, that current a Redis function does not support clustering, but this is definitely filed as enhancement request. Unfortunately, I don't have additional information that when it's coming out. If anybody has that, feel free to chime in. But this is definitely something that on top of mind for many organizations that use Redis with LogStream at scale. Another question is, can that dashboard be shared? Absolutely. I don't mind sharing this dashboard. Just keep in mind that it's a little bit tweaked for demos, but I will share this dashboard in community Slack if that is acceptable. And let's continue with these slides. And unless somebody has any other questions. All right, so now to my favorite portion, which is think about streaming data, maintaining state, things you can do. In this case, what's exciting, you can start pulling your correlation rules from your security analytics tools into the stream. And there are tons of benefits, right? So it offloads your security analytics tool. You can trigger those correlation rules in practically real time. And probably there's a bunch of other benefits, but let's take a look at what this all means. So for anyone who uses Splunk for security, this seems like most likely is a familiar application. Splunk Security Essentials, which is the repository of Splunk correlation rules and a bunch of other things. And I just pulled what came up on the top of the page, filtered by featured searches. And you can see the theme here. So there's no shortage of correlation rules, but they all follow specific patterns and usually end up mapped to in limited number of kind of logical patterns. Asset information match, like for example, somebody touches my GDPR asset, who shouldn't, right? So first occurrence, somebody reached out to a D domain that was never reached out to from whatever, this part of the environment. Threshold exceeded, right? So this is pretty straightforward, not super interesting, but very popular. Pattern matched, we talked about things like log4j or something that you may want to potentially pull that does not exist in your IDS, IPS pattern matching mechanisms, and deviation from the baseline. This is interesting, deviation from the baseline. Basically, it gives you, takes you into that correlation rule that gets you into UEBA-like territory. So for example, somebody was doing a specific set of things for the past 30 days, and suddenly there's a spike or deviation from that baseline. So let's take a look at actually that specific example. Before we do that, we'll actually look at why we can, why this is all important. So with state augmenting stream, we can build baseline and identify outliers. So we can literally maintain that baseline information for a prolonged period of time. We can also catch first-time occurrence events across large time windows. We can match patterns. We can correlate assets with identity and, correlate events with assets and identity data. And interestingly enough, correlating across multiple data sources. Some of the interesting things that I've seen is, for example, matching one data source against a threat intel. It's something very popular. But another interesting use case is feeding vulnerability scanner data via LogStream and maintaining this information as state information and matching data traversing, for example, from your firewalls or other network-related data or authentication data against that vulnerability data. So highlighting some things that match anomalies for network data plus anomalies matching, for example, vulnerable assets. And the second last thing is you don't have to send now all the data to your SIEM, XDR, UEBA. Send something that you actually look at. So you can actually have those correlation rules work in the pipeline and send the digest relevant to your investigations to the SIEM. And important thing, this is definitely way more real time than what you can achieve searching for that data later. Now, we're getting close to the end of me talking nonstop. We will look at our last example. And just bear with me because this is interesting, or hopefully it's interesting. So you can use that, what we described, for maintaining baseline. In this case, in this example, it will be 30 days baseline. And we're catching outliers. So this is not necessarily my favorite example, but for example, catching outliers for lateral movement with authentication information will be even better. So what it means is that, for example, a specific user account on average reaches to, let's say, 5 assets on the network. Maximum that asset reached out to was, let's say, 10, and suddenly it jumps to 200, right? So something that we need to investigate, something that potentially good indication of a lateral movement attempt. So what we'll do here, the pipeline that we'll see next in the live environment, we don't want to be notified about those spikes if they happened once in 24 hours. We want to suppress them. Again, that requires state. If destination is new for the source in the past 24 hours, again, add it to the list, again, to Redis to maintain the state or count. Then third one, add count of unique destinations to the source, for the source to the baseline. So kind of baseline maintaining. Okay, so this specific source reached out to 3 destinations yesterday, 5 destinations the day before, and so on. Then we do a little bit of math, calculation, average, max, standard deviation, and trigger an alert if today, in the past 24 hours, and in our example, since midnight, an asset reached out to more than, let's say, 2 standard deviations away from average, we will create an alert and send it to our destination. In our case, it will be Splunk, but it can be anything. It can be Slack, it can be Jira, whatever you prefer. And then we'll just drop the rest of the events, right? So at least for the purpose of what we are doing there. And with this, we will go to our last demo. And let's make it bigger. So this is the pipeline with this correlation rule. And again, as you saw on the slide, we do basically capture events, put them into Redis. Then basically for every event that is traversing the pipeline, if the destination is unique for that source, then we basically maintain the baseline for the past 30 days. There are some other things, like, for example, cleanups. Like we don't want to maintain baseline beyond 30 days. In this case, in your case, it can be 60 days, whatever your choice is. Redis has multiple mechanisms how you can do this. And I just want to highlight here that Redis can be as simple as 2 commands, set, get, to basically maintain key value pairs. But in this case, I'm using a slightly different data structure, which is sorted lists, right? So it just gives me more flexibility how I can maintain data with timestamps, mapping it to specific dates and things like that. So not going too deep into Redis, but that's how it can be accomplished. Code function here is purely to do math, and if anybody wants to correct me, I will be more than happy to be corrected, because definitely this may be possible to simplify this, but these are simple calculations of standard deviation and averages, maximum of a value, of a list values. So it's just standard math in JavaScript. Then we do our drop for events that just do not match our threshold. And finally, kind of more a rich part of the pipeline creates our alert, right? So an alert, we enrich it with things like, let's give it a name, let's give it a description. Then we put stuff into that alert, pull it from Redis. We will just do a regular LogStream magic with shaping formatting event. And finally, it goes to our destination. Now let's see what it looks like in the destination. This is literally one alert, one event. And this is what it looks like in raw format. In this case, I formatted it as a JSON event. So you can send it in Slack, your Jira, whatever the destination should be for your alerts. And you can add whatever you want, right? So in this case, since I care about the destinations that this source reached out to, I'm listing the destinations, right? I'm saying that it is 36 destinations for this source. The average destinations per day for the source is only 4, and standard deviation is 7, right? So if things work after I refresh it, so I can also see where those destinations are. One is in what seems to be Brazil, if my geography is correct, and the other one is a bunch of them, 32 in North Korea, right? Having done this in the pipe, I can alert it on this much faster, plus get all the rich context. And I don't need to have all the events for having this in my security analytics tool. And with this, let's see what we have here. Thank you so much for saying that it's cool. So, and this is just, if you start thinking about it, and I'm all ears when it comes to things that you want to do in the pipeline. I'm very excited about the capability of doing or creating other correlation rules in the pipeline. So offloading your SIEM, doing something cooler, maintaining state. So things you can do in the pipeline are just absolutely amazing. And with this, I think it's a summary, and then we'll have a little bit of time for Q&A if anybody has questions. Pipeline is absolutely critical between source and destinations for any sizable security environment. If you have just your firewall you're monitoring and maybe your Active Directory server, you will be fine without a pipeline. But if you have even medium-sized environment, you have more data sources and you want to have more visibility. And pipeline for that is absolutely critical. Even in my home environment that basically doesn't have anything, I'm using LogStream as my security pipeline, just because it's more convenient than sending it to my SIEM directly. I can manipulate data. I can run some cool things in the pipeline before it hits my SIEM. And adding context is much easier in the pipeline. Normalized data is much easier in the pipeline. Reducing data is definitely easier in the pipeline. And pipeline is your place to alert in real time. So you cannot really do this very well in many other security tools. So for example, common example would be with Splunk. You cannot really run unlimited number of real-time searches. So that's why if you look at how correlation rules and alerts are set up in Splunk or enterprise security, so they are definitely scheduled. Very few of them run in real time. Some of them run every 24 hours. And in some cases, it's just not necessarily great. You definitely want to be notified faster on anomalies. And again, with adding state, you are expanding the capabilities of your security pipeline drastically. You can do your massive volume aggregations. You can do your correlation rules. You can do your enrichment from asset and identity information, things like that. And I'm not sure what I mentioned replay enough, but replay is a great complementary solution to everything that we discussed, or function, right? So you would typically manipulate your data, and only subset of enriched, manipulated, aggregated data will go to your analytics tool for daily analysis, for other things that you do with your Splunks, Elasticsearches, Exabeams. But for compliance, for long-term retention, you need to send all or most of the data to the least expensive storage, but still being able to replay data on demand from that least expensive destination for the data. And replay function is absolutely fantastic for doing that. And with this, I'm happy to answer questions. If you want to hit me directly on community Slack, you can find me as Igor. If you cannot find me as Igor, try Igor. Both will work. Any questions or any suggestions?
Quiet crowd. Thank you, Igor. That was great. We will have David Maislin up in 2 weeks' time going over updates on the Windows pack for anyone that's interested there. We will have this recorded and up on YouTube as we usually do in a few days. Thank you for attending. If there's any follow-up questions, please let us know.
And I think there's yet another question.
We have a question. Excellent.
So the question is, how many of these use cases are published packs, and how many are custom to this demo? Good question, fantastic question, right? So, AWS VPC Flow pack is a published pack. The correlation rules is definitely something that is more or less custom at this point, custom to the demo. But the beauty of this is that this definitely can be shared, may need a little bit of modification to match your environment. But again, those are not significant modifications and not heavy lift for doing that. And again, do not hesitate to reach out to me directly if you want to build something together or get the bits from everything that you've seen. And I will publish as much as I can on community Slack today. All right. Thank you so much.
Thank you, Igor.
Recording stopped.